Today we are going to learn about mastering Kubernetes ConfigMaps and Secrets. We'll explore how to efficiently manage configurations and sensitive data using Kubernetes ConfigMaps and Secrets, equipping you with skills for secure and effective app deployment. Welcome to our session on mastering Kubernetes ConfigMaps and Secrets. Configuration and secret management are essential components of deploying and managing applications in a Kubernetes environment. Config maps are used to decouple configuration artifacts from image content to keep containerized applications portable. Secrets are similar, but they are specifically designed to hold sensitive information, like passwords or API tokens. Today, we will delve into how these tools work, how to create and manage them, and best practices you should follow. By the end of this video, you will have the foundational skills needed to efficiently handle configurations and secrets in your Kubernetes applications.
Config maps in Kubernetes allow you to manage configuration data separately from your application code. This enables you to change configurations without rebuilding your images. You can create a config map in several ways using kubectl. The simplest method is using literal values, which you can do by executing the command kubectl create config map name from literal equals key equals value. For larger configurations, you might want to use configuration files. You can create a config map from a file with kubectl create config map name from file equals file name. Managing config maps efficiently involves understanding these commands, knowing when to use each method, and organizing your configurations logically. This block will guide you through executing these commands, managing versions, and understanding the nuances of each approach. Once you have created a config map, the next step is to use it within your pods. Kubernetes provides two main ways to use config maps, as environment variables or as volumes. To use a config map as an environment variable, you can specify it in your pod definition under the env field. This method is handy for small sets of configuration data. Alternatively, you can mount a config map as a volume. This approach is beneficial when dealing with multiple files or larger configuration sets. By mounting config maps as volumes, you can update the config map and have those changes reflected without redeploying your application. This block will demonstrate both methods, helping you choose the right approach for your use case and ensuring your applications can dynamically respond to configuration changes.
In Kubernetes, secrets are used to store and manage sensitive information, such as passwords, OAuth tokens, and SSH keys. Unlike config maps, secrets are designed to keep this data secure. You can create a secret using kubectl by encoding your data in base 64 and then running kubectl create secret generic name from literal equals key equals base 64 encoded value. You can also create secrets from a file using kubectl create secret generic name from file equals file name. Managing secrets involves understanding how to encode and decode sensitive data securely, ensuring that only authorized personnel can access it, and keeping your Kubernetes cluster security policies up to date. This block will guide you through creating secrets securely and highlight best practices to ensure your sensitive data remains protected. Similar to config maps, Kubernetes secrets can be utilized in pods by mounting them as volumes or using them as environment variables. To use a secret as an environment variable, define it in your pod's configuration under the env field. This is crucial for integrating sensitive data directly into your application's runtime environment. Alternatively, you can mount secrets as volumes, which is particularly useful when an application requires access to multiple secrets or secret files. Security is paramount when using secrets. Ensure that your pod configurations are set to restrict access to sensitive data only to those with the necessary permissions. We will explore these methods and discuss the security implications and best practices for using secrets within your Kubernetes applications.
Managing config maps and secrets efficiently requires adhering to several best practices. First, organize your config maps and secrets logically, grouping related configurations and secrets together. Implement version control strategies to track changes and enable rollback if necessary. Limit access to both config maps and secrets by setting appropriate role-based access controls, RBAC. Regular audits and compliance checks should be performed to ensure that your configurations adhere to your organization's security policies. Finally, implement a robust backup and recovery strategy to safeguard your configurations and secrets against data loss. In this block, we will delve into each of these best practices, providing actionable steps to incorporate them into your Kubernetes environment.
Even with the best planning, issues with config maps and secrets can arise. Common config map issues include incorrect data formatting and failure to update within pods. For secrets, problems often involve access permissions or errors in base 64 encoding. Kubernetes provides several tools for troubleshooting, such as kubectl describe and kubectl logs, which can help you diagnose and resolve issues. Understanding error messages and interpreting them correctly is crucial for effective troubleshooting. This block will explore common issues you might encounter with config maps and secrets, as well as strategies for resolving these issues quickly and efficiently using Kubernetes tools.
The real power of Kubernetes config maps and secrets is evident in their application to real-world scenarios. In microservices architectures, config maps are invaluable for managing configuration changes across multiple services. Secrets play a critical role in C/CD pipelines, ensuring that sensitive data is securely managed during automated deployments. This block will present case studies and industry applications that highlight the effective use of config maps and secrets. By examining these examples, you will gain insights into how other organizations leverage Kubernetes for configuration and secrets management, and learn lessons that can be applied to your environment.
For advanced users, Kubernetes offers several techniques for more sophisticated configuration management. Dynamic configuration updates allow applications to respond to changes in real time without downtime. Implementing secrets rotation policies ensures that sensitive data is regularly updated to reduce the risk of exposure. ConfigMaps templating can streamline complex configuration setups, making them more manageable. Integrating Kubernetes with external configuration management systems can further enhance your application's scalability and reliability. This block will guide you through these advanced techniques, providing insights into how they can be applied in large-scale, dynamic environments.
Security and compliance are critical considerations when managing configurations and secrets in Kubernetes. Ensuring the security of sensitive data involves using encryption strategies, both in transit and at rest. Compliance with industry standards and regulations, such as GDPR or HIPAA, requires a thorough understanding of your organization's legal obligations. Implementing audit logging can help maintain compliance by providing a record of access and changes to sensitive data. This block will explore these security and compliance considerations, offering guidance on how to implement robust security measures and maintain compliance with relevant standards.
In a DevOps environment, managing configurations and secrets effectively is crucial for seamless integration and deployment processes. Continuous integration strategies can automate the updating of config maps and secrets, ensuring that changes flow smoothly from development to production. Integrating secrets management into your C/CD pipelines can help maintain security while allowing for rapid deployments. This block will focus on how config maps and secrets can be integrated into your DevOps toolchain, enhancing collaboration between development and operations teams and streamlining the deployment process.
As we conclude this session on mastering Kubernetes config maps and secrets, let's recap what we've learned. Config maps and secrets are essential tools for managing configuration and sensitive data in Kubernetes environments. We've explored how to create and use them effectively, discussed best practices, and delved into advanced techniques and real-world applications. By implementing these strategies, you can enhance the security and efficiency of your Kubernetes deployments. We encourage you to explore further, experimenting with these concepts in your projects. Thank you for joining us, and happy Kubernetes management.